sometimes it's easier to see something in action as opposed to reading it. So here's DeepSkyStacker 4.2.2, which is the latest version as of today, September 2019. And I'm just going to go through the process. I'm going to stack some FIT files created by a dedicated astronomy camera, but the same process applies if you're using DSLR images, raw image files captured with your DSLR camera. And I'm looking at some images of the Crescent Nebula I captured last year. These are my light frames that I'm going to grab first. So these are FIT files, so the preview isn't nearly as interesting as the one you'd see from a DSLR camera. You can see a few stars there, but I can see some important details such as the size of the image and the exposure length. So I've got all the light frames there. In this case, I took darks as well, but I don't believe I took any other type of calibration files, so shame on me for not taking at least flats. So I've got my lights and darks all 4 minutes long there. That's on night 1. And then using the group 1 tab, I'm going to open up the light frames from night 2. I can see them with their L designation. That was captured in astrophotography tool. They label them that way. And these were 5-minute exposures. And we're not going to pay attention to the score or anything yet because I want to show you that next. Just going to grab the dark frames here. Let's see, did I have a third night? I changed filters there. So this is with a duo narrowband filter. So I've got a set of images taken 4 minutes long each and a set of images taken at 5 minutes long each with lights and darks for all of them. So the first thing I'm going to do is check all. And then at this point, we can take a look at the settings by clicking Register Checked Pictures. So I'm going to put in Register Already Registered Pictures in there. And then more importantly, in the Advanced tab for this star detection threshold for images like this, because as you can see, there aren't many stars visible in the field. You'll actually, to pick more of those up, you'll have to move the slider down. So you would think you'd move it up, but no, it's down. So knowing these type of images, I'm going to set it at 7% and click the compute number of detected stars. 22 stars isn't a whole lot to register from, so I'm going to bump that down 28 stars. That should be just fine, but you can go right as low to 2% and that'll find 60 stars. That's enough. As opposed to some of the DSLR images you'll be stacking, you'll have over 2,000 stars. In that case, you'd move it way up to find like 500 stars because it will take a long time if you use 2,000 stars to register. So I'll keep that at 5%. I think it was 28 stars. And then look at the recommended settings here. So a master dark using Sigma clipping median combination. Yes, sir. That was a recommended from DeepSkyStacker. And I am going to use the Sigma clipping combination method rather than the auto adaptive. Okay, we are good there. The stacking parameters. Here's a big one here, the enable 2x drizzle. Now, depending on your machine, that may really take a long time. With DSLR images, with a bigger, newer DSLR cameras with a massive image size, that can really take a long time. This one, because the images were bin 2x2 and they're a rather small size, this is recommended to drizzle. There's many advantages of that, but one of them being the image will be twice as big. All of the rest of the settings in here will keep at their defaults. And then now we are just registering the pictures. So this kind of just gives us a breakdown of the stacking steps, including the total estimated exposure time, 9 hours. Holy smokes, that is a lot of data. I don't usually get that much. I must have had some clear nights last year. So I'll register these first, and then when this is finished, I'm going to come back in again and show you what's next. DeepSkyStacker has finished registering the pictures that I selected previously, and it's not so pretty to look at right now, but we're not done yet. So if I just click on Open Picture Files again, that just brings me back to where I can see the files down at the bottom here. Now here we can see that there's a score associated with all of the light frames we've used. So if you look at this category here, there's a score and there's a number assigned to it. So if we scroll down, all of the light frames have a score to it, and we can sort them from top to bottom, which is useful. So this is technically our best shot here with a 645 score. Don't worry about the actual value of this score because that will vary widely depending on your imaging system. But for me, for these images, 645 is as good as it gets, meaning that the stars are the sharpest and smallest, the least amount of trailing, the guiding was good, all of those great things. In the other group, the same thing is here. And if you notice, my top score this time was only 436. So that could have been because of the sky conditions, or my focus was worse, or maybe it's just because of the less exposure time. Either way, it's just ranking them from best to worst as far as DeepSkyStacker can tell. I wouldn't worry about these other values, the DX and the DY and the angle and all that. Just focus on the score for now. Usually, I don't even enter in any images that are really way off as far as star trailing or anything. You can kind of take care of that during the capturing stage. You want to dump and delete all those files that didn't work out, and you don't want to try registering those. So now that I've got these scores and everything's registered, we can actually stack just the best files based on those scores. So where you would do that, instead of clicking check all, do check above a threshold here on the left hand side. And so because I'm really varying between the two groups, you can see that I'm going to have to limit it to, so that's quite a drop off from 175. Look at that, and you can actually see it in the image preview here, from the 175 score to the 645. That's a huge difference. So why don't we dump everything below, I think below 300 would be safe. There is no value in stacking those images. And then that covers the best ones here too. Let's see how many we would be dumping. Yeah, only the bottom half of the light frames for that one too. So why don't we do check above a threshold of 300 score. And if we scroll down, we're going to see that these ones are now unchecked here, so it won't stack those. And that's across both groups. So only the best images, and we can see here that that's going to be 92 light frames and 31 darks. No flats being used this time, although they should have been for calibration. And then now we can do stack checked pictures. And as you can see now, we're at 6 hours and 48 minutes. So that's where you got to make the decision. You want as much integration as possible for that, the best signal to noise ratio possible. But you also don't want to stack any images that show trailing or they have a weak signal, because that's not going to do you any benefits. So by using the score feature and stacking your best images, you're going to create a better intermediate file. And you know what, 6 hours and 48 minutes isn't so bad. So that's just some food for thought there using the score feature in DeepSkyStacker. And hopefully this was useful to you. So I'm going to go ahead and stack that now and let this do its thing, and then I can process my image of the Crescent Nebula. So using those best light frames that I decided on, I've stacked the final intermediate file, and then we can save the picture to file. So it's right under the processing tab here saying save picture to file, and I keep all my images in this folder called DeepSkyStacker space, and I'll call it Crescent New, and it's going to be a 16-bit per channel image, which is what we want for Adobe Photoshop. The autosave output file that it creates on its own needs to be converted to a 16-bit per channel file anyway. So this is what we want. It's going to be a TIFF file, and we can say save, and then I'll go into Photoshop and open up that file. Okay, so here it is, Crescent New, and it looks almost completely black, which is totally normal. And at this point, you might be freaking out, saying like, "Oh no, something's gone horribly wrong with DeepSkyStacker. It does not work." But that is not true. If we open up curves here, we can see all the data just sitting right here at the bottom. And by doing a curve stretch, bringing the data up aggressively, we can see the underlying data is sitting in there. I'm not going to process this image fully right now, but I just want you to see that the data is indeed in there. If we go in the channels, we can see a bit of the red and the green. With this camera and it's this color camera, the green channel is always the strongest signal just because of that Bayer pattern. So I'll do another curve stretch so you can see the data in there. And that's kind of the name of the game for processing astrophotos. Several smaller iterations are better than, fewer massive stretches. So there we go. There's our Crescent Nebula in there. And if we look at the channels, we can see some really impressive details in there. As you can see, the green channel is the brightest, so I'll just bring that levels tab down on the side. And now we're getting something that looks a little bit more like the image that I'm sure you were all hoping for and expecting. I just do a quick set the black point here, and there it is. So there's our file that was created in DeepSkyStacker, and if you can already tell how great this image data is with 6 hours of exposure. I'm not seeing a lot of noise in there. It's nice and smooth. We can really play with this data now the way we want to, and really pull out some faint details that are hidden, lying waiting for us to find them in this data.